Hello everyone, my name is Ketuktula Zulu. I'm the man behind the content. The purpose of this channel is to make everyone that is in high school from grade 10, grade 11 and grade 12 to grow under mathematics. That is my purpose, to make everyone pass this subject. So now I would like to thank everyone who's been supporting me on this channel. Guys, thank you so much. I really appreciate your support. And another thing, please, if you are watching this video, you haven't subscribed, please subscribe, like, comment, tell me what I need to improve on, tell me what you want on this content. I really want to engage with you. Thank you so much, God, for supporting. Cheers.
Okay, good afternoon, guys. Makebalo. Today we'll be doing some differential equation, doing a revision from the June exams that are going to be written now in June. So I hope you will enjoy the lesson. You'll enjoy everything on the lesson. We'll be doing some more of the derivative questions that we have here, which is question 8, where we deriving using first principle. So the first question is 8.1, where it's saying f at x is equal to 4 minus 3x squared. So from here, from knowing our general equation, when saying f prime of x is equal to lim into h approaches to 0, then into h plus x plus fx plus h, then minus into f at x into h. Now we can first find our x plus h by saying 4 minus 3, then we substitute x plus h all squared, and then 4 minus 3 x plus h is just x plus h into x plus h, then 4 minus 3 and x times x, which is just x squared, x times x, which is just xh, xh, which is just xh, and h times h, which is just h squared, and then 4 minus 3 and then x squared, the like terms, is 2xh and then h squared. Then from here it's 4 minus this times this is just 3x squared, and this times this is just minus 6xh, negative 3 times plus h is negative h squared. Do you have any like terms here? I don't think so. We don't see any like terms here. Then we can go back to our equation here, which is f prime of x is equal to lim into h approaches to 0. Substitute our f into x plus h, which is just 4 minus 3h squared minus 6h minus 6xh minus h squared, and then minus this minus into f at x, which is just 4 minus 3x squared all over 1 h, then lim h approaches to 0. Take this as it is. This times this just minus 4. This times this just positive 3x squared. Having the like terms here, this 4 cancels this 4. This negative 3x squared cancels this negative 3x squared. Then all over 1 for h, where lim into x lim into h approaches to 0, we're gonna left by negative 6xh minus h squared all over h. Then lim into h approaches to 0, we have h, meaning h is a common factor, so we're going to just have h into negative 6h, negative 6x, then minus h into h, and then from here we just have limit again into h approaches to 0, then minus 6x, this h cancels this 6, this h, and then minus h, and then from here substituting our 0 to h, there is no need of now putting what the lim, just going to be negative 6x minus 0 into just negative 6x. Then this is our derivation using what first principle. So we will continue with another example where now we do the dx into x4 minus 2x, then plus 1 over x squared. Now this one we are deriving this one. Now this one is a little bit different because this x here, this x with the exponent or with the power is on the denominator. So first you must take this x, which is the base, and this exponent up to the numerator. By doing that, the sign of an exponent changes the sign. So it's just going to be continued our dx, since we haven't derived yet, and x to 4 and 2 into x, and then now plus x, but now the exponent going to change the sign, then it's going to be negative. And from here, when it's like this, now we can derive. Now everything is in order. By deriving this, we're just gonna, now the dx is not gonna come back since we are going to derive. Then the dx just gonna disappear. Then you're gonna have 4 into x3 by this times this minus 1 and minus 2, and then here this time is just going to be minus 2 into x minus 3. 1 minus 1 is 0, anything raised by 0 to 1, then 1 times this negative 2 is this negative 2, negative 2 times this just negative 2, negative 2 minus 1 is minus 3. But we can't leave our answer in the negative exponent, we need to leave our answer in the positive exponent. And this negative 2 to this negative 2, taking this, the base and its exponent, to a denominator, we leave this coefficient here, it's just going to be x into a positive exponent, which is 3. Then we are done with deriving this one. Let's move to the another one where we have y into 2x minus 3 all over the fourth root, where we are deriving this in terms of dy dx. By this one, when I use this thing here, where we have let me say 3 over 5 minus 7 over 5, where the base is the same. How do you minus the fractions when you have same base? Take one base, and then you're saying 3 minus 7. This is the same as this. You take one denominator and then you minus what? The numerator. Just going to do the same thing here by taking this to this form, by just saying 2 into x into 4 cube root of x, and then minus 3 into 4 into cube root of x. This is the same as this, just as now we have variables, we have x and everything. Then from here, I'm just going to say 2 into x, removing this cube root, okay guys, now we'll look at the other part, the other question, where we have y is equal to 2x minus 3 all over fourth root of x, where we have to derive this in terms of dy over dx. Now what I'm going to explain here, I'm just going to say 8 over 5 minus let me just say 9 over 5. Right, now how do we minus these fractions? Minus fraction by taking the denominator of a fraction, since those denominators are the same, and then you minus what? The numerators by just saying 8 minus 9, like this. So I'm just gonna do the same thing as this, since this is the same as this here, by just saying y is equal to 2x all over the fourth root of x minus 3 into the fourth root of x. This is just the same as this, as also this is just the same as this. Then from here, simplify 2 into x into changing the roots there, which is just going to be x into 1 over 4, and minus 3 into x, which is just going to be 1 over 4. Same base, division sign. You take one base, say 1 low ayangaphezulu minus 1 over 4, then minus 3. This space, I need exponent going at the top in the numerator, change the sign, which is going to be 1 over 4. We still have y, we haven't derived yet. Then y is equal to, we have 1 minus 1 over 4, 1 minus 1 over 4, we have 2 into x into 3 over 4, minus 3 into minus 1 over 4. Then from here we can do our derivative. We'll say dy over dx, since everything is to order, then it's going to be just 2 times 3 over 4 into 3 over 4 minus 1, and then minus 3 times this 1 over 4, then x into negative 1 over 4, then minus what? Minus 1, and dy dx, but it's just 2 times 3 over 4, it's just 2, it's just 3 over 2, then 3 over 4 minus 1 is just x into negative 1 over 4, then this one is just going to be negative 3 over 4 x, that is negative 1 over 4 minus 1, it's just going to be negative 5 over 4, but you don't leave your answer in the negative exponent, so it's going to be dy dx 3 all over these 2, this whole thing come to the denominator, it's just going to be x into 1 over 4 minus 3 all over 4, all this thing come into a denominator, it's just going to be x into 5 over 4, and you can leave your answer like this, it's fine. Thank you so much. And then now we have a specific question, or an interesting question, where they are saying f at x cubed minus 7x squared. They are saying calculate the x coordinate of a point of a graph, this graph, at which the gradient of a tangent is equal to 5, at which the gradient is equal to 5. They're telling us the gradient is equal to 5. I hope you still remember how to find the gradient of a tangent. The gradient of a tangent is a derivative of a function. That's how you find the gradient of a tangent. How do you find it? You derive your function. How do you derive this function? It's just 3 into x squared minus this times this is just 14 into x. This is how we find the gradient of a tangent. That time they give you the x coordinate. Then you take your x coordinate, you put it here, you put it here, you get your gradient. But now we don't have the x coordinate, we do have a gradient. So we're gonna use our gradient, which is f at x uyalingana nani ne gradient, and the gradient is 1 5. We're gonna find what that x coordinate. So we're just gonna say 5 is equal to 3x squared minus 14x. Then from here, take this 5 to the other side, it's just gonna be 3x squared and minus 14x and then minus 5. Then from here we can factorize. If you know how to factorize, if you don't know how to factorize, you just punch the quadratic formula. Let's just do the quadratic formula for now. Squared minus 4ac all over 2a, then x into negative b is just negative 14 plus or minus into x, negative 14 all squared minus 4a, our a is 3, our c is negative 5 into 2, our 8 is just 3. Then punch a calculator. X into negative 14 plus into negative 14 squared minus 4, our a is 3, our c is negative 5 over 2, our a is 3, and our first x is 5, or our second x just gonna be negative 1 over 3. These are the x coordinates that we want. These are the x coordinates that we want. Let's check, because one of these x coordinates has to give us a gradient which is 5. So we need to check which one is the x coordinate that we want. Now let's check. From 3 into 5 squared, we're checking here because it has to give us the gradient of what? Of 5. Then minus 14 into 5. Do we get 5? Yes, we get 5 when I'm substituting 5 in this derivative. Let's check. Negative 1 over 3, negative 1 over 3. Do we get 5? Yes, we do get 5, meaning both of them, they are correct. Thank you so much.